From wisdom in leadership, we move to high stakes performance, where pressure is constant, consequences are real, and small decisions can make a major difference. With his keynote, Managing Error and Enhancing Performance in High Stakes Environments, Lessons from the Flight Deck. And with his feet now firmly on the ground, here's former Aer Lingus pilot and captain Niall Downey. Niall.
Thank you, Wasim. Let's start with a question first. Has anyone here ever tried to land an airplane but forgot to put the wheels down? No, I haven't either, I'm glad to say. I'm guessing you probably haven't, but I'm sure you have made mistakes at work. We all make mistakes. It's part of being human. Those mistakes have consequences. They can affect your clients. They also affect your staff. Staff come to work to do the best they can. When it goes badly, they get affected. And lastly, it also affects your bottom line. It affects your profit margins. So we have a problem. It affects all industries and all walks of life, but we have a solution. I spent 6 years as a cardiothoracic surgeon and the last 27 as a commercial airline pilot. And the airline industry has been working on this for about 50 years, and we have developed a solution. The solution is a human factors approach. We expect to make mistakes. The problem is that our brain, as Risha has been explaining, it doesn't work the way we think it works. It's evolved over a couple of 100,000 years. Our environment has evolved an awful lot faster over the last 100 years. So we're now basically trying to navigate a complex 21st century environment with the brain still running on caveman software. Our brain is an amazing bit of kit, but it has limitations. We've now reached those limitations because of evolution. So I'll give you an example. Have a look at this grid and see if you can see the black dots. So how many black dots can you see? I'm guessing you can see one or two, but as your eye strays across the grid, you can see more and more. There's actually 12 there. The underlying problem is if you put your thumb out like that and look at your thumbnail, that's the total amount that your eyes can focus on at any given time. Everything outside of that is blurred. The way your eye works is it takes snapshots and then fills in the gaps with what it thinks is there, not what actually is there. And what you think is there might not be what I think is there. So seeing is not believing. I'll give you another example. Have a quick look at that and tell me what you think you see. Now, I'm guessing you're seeing a young lady levitating on a beach. Your brain works by taking shortcuts. It's 3% of your body weight, but it uses 20% of the energy. So it's had to evolve to try and be more energy efficient. Back in caveman days, energy was survival. So the less energy you could expend, the better. So your brain has learned to take shortcuts or heuristics. It looks at pictures like this, goes back into its memory bank and goes, oh yeah, I know what I'm seeing here. That's the levitating picture. You're actually seeing, if you look more carefully, is a young lady lying on a beach beside a black towel. So again, we don't think the way we think, and we don't see what we think we're seeing. And one more look. Again, back into memory banks. Memory bank looks at this and thinks, oh yeah, that's the corridor memory bank. And you can look down a corridor in 3 dimensions. And you can turn and you can look down another corridor. That's not actually what you're looking at all. So your brain makes mistakes. It makes errors. Now, the shortcuts we take, the fancy term's heuristics. Now, they work extremely well generally. They've been very cost effective and very efficient. But there is a cost. There's a margin of error. Now, as I say, it's been very effective for millennia. In the last 100 years, our society has evolved extremely quickly and our brain hasn't evolved to keep up. So the margin of safety has got tighter and tighter. That margin of safety is now inside the boundaries of the margin of error, and it's in the gaps that the adverse events or the problems happen. And that's what we need to address. The bottom line is we don't think the way we think, and that's what we need to sort out now. Human factors narrows the gap between the two. So what about costs? What sort of implications does this have? As I said, I used to be a cardiothoracic surgeon in the NHS. So if we look at some numbers from the NHS, just for comparison, they've done a lot of research, a lot of other industries haven't. Numbers-wise, the NHS has acknowledged that human errors or mistakes cause about 11,000 deaths per year. Now, depending on how you cut the numbers, it could actually be 4 or 5 times that, but let's be conservative, 11,000 deaths per year. There's also a lot more people get hurt, either seriously hurt or at a lesser level, but there's a huge impact from this. If I want to put it in context, here's what I fly. It's an Airbus A330. It holds over 300 people. If you look at the NHS numbers, the NHS is crashing one of these planes every 10 days with no survivors. Now, they've looked at implementing human factors, but they haven't really done it in a complete way. They've taken it piecemeal, and that doesn't work. Basically, what they've done is they've taken the bits of aviation safety that they like and have tried to transplant it. It's a bad tissue match. It's not the same industry, but the underlying DNA is very similar. So we can take a genetic engineering approach and engineer it in. So that's the human cost. As I said before, this affects the staff as well. They're called the second victim. When a staff member injures a patient, they carry that with them for years. I remember instances that I've had 30 years ago and I still carry them with me. It increases the amount of sick leave and it increases the staff turnover, all of which has costs. If you look at the number, the NHS estimates that the total cost is about 10% of the healthcare budget. Now, research has shown that's the same sort of figure worldwide. So in UK terms, that means there's £20 billion being wasted because of human error, even though there's a solution there that we could try to implement. They reckon in healthcare research that 70% of that is avoidable. So that would save about £14 billion a year for the exchequer. And I think we all agree we could do quite a bit with that sort of money. So 70% in some industries. Our industry has done even better because our starting point is we assume that error is nothing to be ashamed of. We expect to make mistakes, so we think nothing of putting our hand up and admitting them when they do. That means we then learn where the problems are, so we know then what we need to address. We have a three-step system. So it's a three-legged stool, and we have to implement all three legs or the system doesn't work. First is adjust culture. That means I can put my hand up, safe in the knowledge that I can't be disciplined and I can't be dismissed. Now, it's not a get out of jail free card. If it's gross negligence or if it's deliberate harm, I'm not protected for that and I can be charged with that and work through the justice system. But generally, we all come to work to do our best. So now that we know where the problems are because we've reported them, we can then have a look and see, well, what went wrong? And notice what went wrong, not who went wrong. Other systems like healthcare are still stuck in the name, blame, shame and retrain system. We take a systems approach and think, well, if you were so poor at your job, why did it take you 25 years to make that mistake? So we assume it's a systems problem. We then look at the different layers of the systems, like a Swiss cheese model. Each layer is a slice of the cheese, and each of those slices has threats. Those threats are the holes in the cheese. We then see how we can plug them. So basically, we take out the tripwires and try and add in safety nets. Every accident we've investigated has at least 6 or 7 layers. And unfortunately, the threats keep changing every day, so it can be quite difficult to keep an eye on. Lastly, crew resource management is our system for trying to look ahead and try and anticipate problems. We try and stop them as best we can, but we accept that some are still going to go through. So we actually have an avoid, trap, mitigate system. We try and avoid mistakes as best we can. We try and trap those that get through, and then we try and mitigate ones that have got further down the line before they cause too much damage. So again, to look at the Swiss cheese idea, here's a very good example. Each one of those layers is part of the system, and each part of the system has its own threats, whether it's tiredness, people with sort of training problems, mechanical problems with the plane, weather systems, so on. It's only when all the holes line up that we actually get the incident or the crash. So our job in human factors is to try and plug as many of those holes as possible. Now, I started off by asking you, had you ever landed an airplane without putting the wheels down? That's an issue that we've addressed in aviation. When I come into land, there's a lever sticking out of the dashboard right in front of me where I can't miss it, which has 2 rubber wheels on it, and your options are up or down. So that's the most obvious way of plugging the hole. We actually have multiple layers again. When we're coming into land, we have standard procedures of when we take them down. We have paper checklists, we have electronic checklists, we have each other to monitor each other. And lastly, as a last resort, once I blow about 800 feet in an Airbus, it will actually start talking to me and say too low gear. So does it work? Here's a chart showing the number of accidents or incidents over the last 100 years or so. We can see there's a steady climb to the late 70s and a steady drop off ever since. Bit of a blip for the Second World War, but apart from that, a steady climb. Similar number of deaths, steady climb to the late 70s and a steady drop off ever since. The late 70s, after the Tenerife disaster, is when we started implementing our human factors approach. If you follow the trend, there was about 3,000 deaths per year back in the late 70s. Aviation has increased about tenfold, so we should be expecting about 30,000 deaths per year in commercial jet aviation. We actually have less than 1,000. That's a 97% improvement. So our system does work, and it is relevant and it is transferable to other industries. So if you're interested in transferring it to your own industry, I can encourage you to, first of all, you could read my book, Oops, Why Things Go Wrong. And if you'd like to hear more and work out how we can optimize your caveman software, if you want to get in touch with Bob, we'll try and find a slot in my calendar and I can talk to you and your team. Thanks for your time today.